Right, welcome everyone. We're going to start now and we'll welcome everyone as they come in. So my name is João Falcão. I'm a PhD at Carnegie Mellon. I'm here with my colleague and friend Carlos Ruiz, who's right here.
Hi everyone.
From IFI. And we're going to present this the results of the AutoCheckout competition. We're going to spend some time showing also the process of the competition for those who did not participate, the results, and then the winners of the competition who will get prizes, the top 3 of the competition. So first of all, I want to really thank the organizers. I already mentioned Carlos, Professor Pei Zhang, Professor Heiyang No, and Professor Shijia. They were really helpful in making this happen and getting everyone together and really making this happen. So here's where I'm from Carnegie Mellon, Carlos from IFI, Professor Pei from Carnegie Mellon, Professor Heiyang from Stanford, and Professor Shijia from UC Merced. And this would not happen without you, the participants, without the competitors. Who are we? Who are you? Where are you? And oh, let me just. Yita is trying to get in. So who are the participants? We had 8 teams submit applications, and from 4 continents, which was quite interesting. We had people from Stanford, Carnegie Mellon, Harbin Institute of Technology in China, UC Merced, Georgia State University, Florida International University, Tsinghua, Berkeley, Shenzhen Institute, TBSI, RMIT, University in Australia, University of Georgia in Greece, and we had an industry participant, HEB, from Texas in the US. And here you all are. We had 8 teams spread like this. I'm not going to attempt to say all of your names, but I'm really thankful for all the interest in submissions and all your engagement. Without you, this wouldn't have happened. And here's all of your affiliations. So why autonomous checkout? Why did we create this competition? So the waiting line is critical part of the retail industry. Who amongst all of you hasn't waited in line and wished you weren't there and wished you wanted to go home? Imagine if you could just walk out and you had already your basket checked. So what does that translate? That's actually 37 billion hours in America alone. And that translates to 4.4 billion potential productive hours, which financially is 108 billion in hourly wages lost and 130 billion in productivity lost. So this is from the people side. So how about from the retailers, from the people who operate the stores? Having autonomous stores also is beneficial for them. Convenience stores face out-of-shelf stockout rates of 5 to 10%, which in turn translates to 4% of sales loss. That's 93 billion annual losses in North America alone. In today, with our friend COVID-19, this technology in this field is even more important. The ability to I see a raised hand.
Does that mean they want to ask a question?
I don't know. I'll just continue. If you want to say something, please do. So as I was saying, the safety of the employees who are now considered critical part of the society, like medical industry, but in the retail industry, they're the ones who keep us fed. We need to get our food, get our toilet paper. So in order to protect them, this technology could get them to focus more on other tasks than doing human interaction at the cashier. So what does an auto checkout store look like? We started with a small concept. This is an architectural diagram of the store that we wanted to put in Sydney. Unfortunately, we couldn't go there. Our intention was to go there, build this amazing store for all of you, and you'd be able to run your own scenarios. But we did it here instead. This store has 13 cameras. These are Armcrest cameras. I'm sorry, 12 cameras. These are 12 5-megapixel cameras. They're powered over Ethernet. They're IP cameras and 2.5 millimeter lens. On top of that, we added weight sensors. So the weight sensors you see in this picture are actually developed by iFi, the sponsoring company. And you can see that we have 2 load cells per one small plate, and that is 12 plates for one shelf. There's about 6 shelves per gondola. A gondola is a set of shelves, and we have 4 gondolas in our store. And in those shelves, we have a 24-bit ADC, and each plate has a 10-kilogram capacity. So we instrumented the store in order to provide you the data so that you can compute the receipts for the people that are shopping. So this is how it looks. You've probably seen this. For those who participated in the competition, you've seen a lot of this. Here's what we provided to you. Okay, so we had 12 video angles, and we also provided the 3D location of all these elements in the store. The shelves, all of these small squares that you see are the placement of the products. We've provided 3D positioning of the cameras as well. And everything is relative to that small black dot in the bottom of the shelf, which is our 000 of this 3D world. This allowed for you to run vision algorithms, location association algorithms, all in one relative space. And of course, we've provided the signals for every single plate on the entire store, 288 plates. And there we are. We also provided upper body key point tracking. So you see me and Carlos over there. We've provided those key points that you see on the right side: head, shoulders, neck, elbows, and arm and hands. Along with the video as well. So having all of this information, we then wanted to recreate shopping scenarios. We started off with our baseline cases, which were scenarios that myself and Carlos enacted. Simple cases, one person goes in, picks up, in this case, 3 items and walks out. We did several of these. Actually, we have 30 baseline cases with enacted by me and Carlos, and some of them have 2 people, and some of them have 3 people in them. During the competition, for all of you who are there, first day, we've created some test cases by request. So people wanted to try their approaches. Teams wanted to see if their weight algorithm worked when 2 objects were picked up at the same time, like this. Or if the vision algorithm was able to distinguish the red chips versus the black chips. And so we've recreated also around 20 scenarios in this case. And then here, what I'm showing is an example of the output of the receipt that the teams have provided. As I said before, we provide the key points with a color, and that color is represented by that number over at the right side, and then a list of products with the barcode of the product and the quantity that was picked. In this case, the two chips are represented by those two barcodes. And all of this was possible through a portal provided by iFi. I have to thank iFi for all the support. Carlos here is representing them. This portal was essential to the success of the competition. All the teams were actively submitting results and seeing the results in real time, and that was extremely useful for the feedback and made it all possible. So the animation is broken here. Some competition statistics. We had 32 baseline cases with 24 single person, 6 2-people shopping, and 2 3-people shopping. For those thinking about COVID and social distancing, I do want to say that Carlos is my roommate. So social distancing wouldn't apply there. And the scenarios that I'm quoting there on 3-people shopping, my wife was also present. So all of us share one place. So there's no problem there. For the requested cases, we had 28 of those. Also 24 single person shopping, 6 2-people shopping, and 2 3-people shopping. It was quite interesting to see that teams were not challenged each other on the amount of people. Also, we didn't have that many actors, so it was this is what we were able to provide. We had, like I said before, 8 teams over 4 continents. There were 9 universities and institutes involved in one company. And this might even have changed by now. The portal was closed at midnight, so this was before I was making the slides. There were 1,758 receipts submitted. This means that for every test case that you've submitted, I counted 1 receipt. And teams have submitted multiple receipts for a test case to improve their scores. The breakdown I made here is we had a session before the competition started to make sure everyone was familiar with the portal and being able to submit their results. And we had about 1% of the submissions during the dry run. And that was empty receipts, just seeing if they could submit. The first day, I think it was actually from team 3. We had quite a few submissions immediately. I think you had your system was ready early on, and then as usual, last day submissions. We had 90% of our submissions were during the last day, which is today, and 80% of those were in the last 4 hours. And again, these are from when I built these slides. They might have been increased by now. So what is a submission and how do we generate these receipts? Basically, we've provided the 12 angles and all the weight cells and all that data, and the teams have downloaded the scenarios. They run it through their systems and generate the receipts, and then they make their submission to the iFi server. At the same time, Carlos and I, who were here during the recordings, would take the objects out, scan them in a regular barcode scanner, and annotate the ground truth, and submit it to the iFi server. And that allowed us to have immediate feedback for all the teams as they were submitting their results. So now I want to make sure I mention all of the approaches that from the teams that submitted. So team one had was attempting to do multi-model fusion, which is leveraging the weights scale with the vision, and do believe that this is a great idea, and the way they've went about it, they've covered probably the most amount of cases. It comes down to implementation, and we'll see in the results how it went. Team two focused solely on video. They were attempting to do product recognition, pickups, everything without using the weight cells, which has lots of advantages when it comes down to misplacements. And however, I'll in the further slides, I'll show some of the challenges that us, the organization, had to provide you the data for your models, for your visual models. Team three, who's on the call here now, did multi-person shopping for cashless stores. I believe it's a combination. It's the focus of the approach is on the association piece. I think that was quite impressive, seeing you had very early results. You were one of the ones that submitted early on. And I know that over the span of the competition, you've improved your algorithm and you've submitted better and better results. Team four was the HEB team, the industry team. I want to mention something about them. Unfortunately, they weren't able to continue with the competition. Their company, when COVID hit all of us, shifted their entire focus into their stores. Their mission is to feed Texas, and all of their engineers felt they had to prioritize that. However, I do want to highlight that some of their team members still attended the conference, still attended the competition, and were very engaging, and also helping out and creating scenarios for us as well. They're eager to be able to participate in the follow competition follow-up. Team five, location-aware multi-model sensor fusion for computational efficient autonomous inventory systems. Team five also had some difficulties in the beginning, but came strong at the end, and I'll show those results. Their focus was they focused mainly on vision in the beginning, and then added on the weight. I think the opposite happened with team three, where you focused mainly on weight, and then had intentions of adding the vision later on. I don't think you had enough time, but still you were able to produce some good results. Then team six, autonomous checkout for retail stores, multi-customer monitoring. Team six was focused as well on the association piece, on the multi-people. Again, that's one of the biggest challenges in this problem. You have product recognition, knowing which product left, and association, who picked the product. The tracking piece was provided by us. Team seven, uni-model sensing using embedded weight sensors for fully autonomous store checkout. This team was actually quite reversed from the others. They solely focused on weight. They believe they're actually improving upon some prior work, some prior publications from Carl's and myself and the team, and they've generated results that surpass that using only sensors. And our last team, but not least, the focus of this team was to understand misplacements. So as this is a competition, the intention is to generate scenarios where the teams performed really well, and then try to get the other teams to not do well in those scenarios. So this team was focused on a specific edge case, which was misplacements. So moving on to results per scenario. So what we're seeing here is on the x-axis, you see the scenario. Those are the titles, baseline 1 through 30, and then the team's requested scenarios all the way to the end. This plot was evolving through the competition, which was great to see. And I'm extremely happy to see that there are so many 100%. It's actually interesting to see that test 6, day 1, test 1 is 0. There's a couple of zeros. And I'll show in some of the scenarios ahead why these scenarios may be so challenging, and why some of the approaches that went only for weight or only for vision might have not picked up those particular test cases. But it was, and on the y-axis, what we have is the F1 score from the receipts. And in this case, it's the maximum score of submitted by any team. So why is it hard? And why do we have zeros in some of these scenarios? So on the left, you see me, and I'm actually putting a very light AirPod on the plate. That's the intention there was a foreign object that is light on the shelf. Would that be picked up or not by the system? The middle one is actually quite interesting. So some of the boxes of these products contain lots of quantity of that product. So in this case, if you were looking at the weight, you'd also see the weight of the box, which is something that is not available to the teams. And if you're looking at vision, you also see all of it on top of each other, which would be very hard to count. So quite interesting and challenging case. Some of the teams did well on that one, which was quite impressive. And then the last one, Carlos decided that the store wasn't tidy enough, so he decided to do some reorganizing. So fast motion pickups and fast put downs, and at the end he picked up only one item. All of that has to do with whether weight or vision approaches work well. So it might seem trivial in the beginning, but by looking at these and really doing those sessions and all the crazy ideas that people had about the scenarios, really emphasizes how challenging this domain is. So observations, findings, and other notes. What worked well for the competition? Throughout this process, this is the first time the competition is running, so we were setting the standard here. And we had 2 clarification sessions before 2 months before the competition started. I think they were very useful. There was a lot of engagement from the teams and lots of questions that helped us organize the competition better. Out of that came out the idea of the portal. Out of that came out lots of data that was required for this competition to run. We had last Friday a dry run session that allowed all of the teams to submit results to the portal and get their systems working, so that during the competitions they could focus on improving it. We had amazing support from CPS Week. I have to really thank Wen and the team for the support on organizing Zoom, the accounts, coordinating with all the other conferences, make sure that we had our place here. Even amidst of COVID, I think all of us suffered, but the organization there suffered especially, and this is an amazing and successful program. And then the interface for submission, that was great, and here's just the portal and how to create users, how to create test cases, how to submit test cases. And for this, I really have to thank IFI, specifically Carlos Ruiz, Will Hendry, Tomas Rivera, and Brian Bates. They've all done an amazing job in helping out at all of this. Brian Bates was the one who built in the portal. Let me just admit this person. Tomas Rivera helped out with all the automation scripts to upload all the data to you within minutes. So as we recorded scenarios, they were available within 2 to 3 minutes, which really enabled this competition. Will Hendry automated the metrics and how to do the F1 scores and comparisons, and Carlos Ruiz was our amazing actor who enacted all of your scenarios and some myself. So thank you all. Okay. So roadblocks, COVID-19. Well, we've said a lot about it. We really it was a blessing and a curse. The blessing was we did not have to build an entire store in Sydney, which for iFi saved money, and for myself a lot of headaches with building walls and insurance and all of that. But obviously not a great outcome. Products scanning was time consuming. So you see those product images right there. In order for the visual models to work well, we had to scan the products that were in the inventory. However, we were hit with COVID right in the middle of that process, and we had to leave the office and we couldn't come in and do our recordings. And that kind of affected a little bit the performance there. I do again have to thank iFi for all that support. They actually provided data sets that were already collected beforehand to help out with the competition. And then time zone coordination, all the meetings and Australia time, European time, US time. It was an interesting challenge, and I think overall, I think we really got your support joining all the sessions. We got US people joining the Australian sessions. We've got Australia session joining the dry run session. So really appreciate all the effort and all in just making this happen. Okay, so this is an amazing case that actually Professor Pei said, what if we just throw all the objects onto the floor? What would happen? So Carlos went out and did it. And personally, I was expecting the teams to not do so well here. It's a very, very challenging case. But this is, I put this one here because it's a very good finding, which is Team 3 got a F1 score on this scenario of 97%. And that was very impressive. It's a very impressive result. It's very noisy sensor information and very visually hard to detect. So congratulations, Team 3. It was a virtual applause for you. So now we're at the time of the team's presentations. I asked the teams that are present to have 1 or 2 slides to present your approach and your findings. What how was the competition for you, and what did you learn from it? Maybe we can start with Team 3 because I think you're eager to go ahead and you're ready to do it. And I'm gonna look through the list and see what other teams are here.
I'm gonna show the slides.
Okay.
I can talk first. So are you guys able to see our slides?
Yep. Yes.
Sounds great. Sounds great. So we're Team 3. We're from Carnegie Mellon University. We provide an end-to-end solution for autonomous shopping and receipt generation. So at the center of bottom center of the slide is our overall system structure. So our overall system contains three major modules. The first module is the wait trigger. We use a sliding window to trigger active events. We would record the trigger begin time and the trigger end time for each of the events. And based on the play data of the trigger begin time and the trigger end time, we would calculate a delta weight to be used later. And after the wait triggering, we have detected a lot of the events and we sort them in a time order. Then we would enter the second module, which is the product identification. So the major product identification is based on arrangement and weight. And oh, I forget to mention that we have split the situation here. We put the purchase event and the put back events into two situations. So for the purchase event, we are calculating it based on the arrangement and the weight. We will calculate two scores and combine them. For the put back event, we actually only take the prediction from our current shopping cart. This is very reasonable, right? You cannot like put something not in your hand back to the back to the shelf. So if the delta weight is positive, which means that we are putting back something. So we're making the predictions from our own shopping cart. And also at this stage, we would refresh the planogram in real time, which means that if we put back wrong item, if we misplace some items, then the whole shelf the data would be refreshed. And later, if we pick up this misplaced item, and it would be existed at the planogram. And the last module is the customer association. We have developed multiple human key points based association methods. One of it is to associate the product based on multiple body parts with their confidence scores. For example, we have the key points for the head, for the hands, and for the wrists, even for the elbows, and the corresponding confidence scores. We would use the confidence scores as a weight factor and then combine all the scores. And besides that, another alternative we take is to compute the distance from the closest body part possible. And this is reasonable because sometimes people would cross their hands to buy products. And this time, if we use the overall body, it's going to be wrong. And of course, we have a confidence score threshold here, which is sort of like a magic number, because we have to make sure that this body part is confident enough. Then we can take this body part as the factor to calculate the distance. So this is the main body of our system. And we also deployed a lot of the tricks because there are around 60 cases. There are a lot of very tricky cases. If you look at the top right, we are sharing some of our tricks here. The first thing I want to share is the multi-product pickup and put back. Since people could pick up two different items on the same shelf at the same time. So in this case, we would split the event. We would group the plate on the same shelf so that each group could generate a different event based on the delta weight. And we have also enabled multimodal synchronization. One thing you might encounter is that the planogram data and the frame data, like containing all the targets, they are not synchronized. The video and the planogram and the weight sensors, they're not synchronized. So we would retrieve first, detect the weight trigger time and the weight end time. Besides that, we also would retrieve a weight peak time. The weight peak time is the time that the weight sensor is changed most significantly. So we would retrieve the targets based on the peak time, which is more accurate than the trigger begin time and the trigger end time. And another thing I also want to share is the dynamic planogram. And I just mentioned this point before at the product identification. So we would maintain a real-time planogram and refresh it. I think this is our overall system. I'd like to take Q&A, see if you guys have questions, and if my teammates has points to mention, you can also start.
Thank you, Shenhui. I have a question. So what did you see as a challenge for this approach during the competition and the scenarios that the teams requested?
So actually, along this road, we have encountered a lot of the challenges. And I'd like to mention one challenge is the synchronization, because no matter you are using the weight sensor based or multimodal or only vision based, we still need the kind of like need something to trigger the event and need to synchronize the time to get the correct frame from the video. And I think this is one challenge I'd like to mention. And another thing I'd like to mention is the something that we struggle is the fine grain. I would like to say that define that as fine grain classification. So, for example, if some products, their locations are similar and the weights are similar. For example, the same brand water, but of different flavors. This time, our method, our solution is hard to identify it. So I do believe probably to train a fine grain classifier could solve this situation, but we find that it's really hard and it's still yet to solve.
Great. Any other questions?
I have a question about when you talk about the customer association with the vision method, how do you combine the weight sensor and the vision confidence together?
So as I just mentioned, when we calculate the association score, we actually didn't use the weight sensor. The weight sensor here performs a role to provide the peak time, which is the time that we need, the exact frame we want. So we get this peak time, which is when the weight sensor changes most significantly. Then we use this peak time to search the database, search all the video frames. We get the exact frame that we need. And within that frame, we have the key points for the head, for different body parts and their confidence scores. And we have two methods to calculate the association score. One is sort of like cross entropy. We combine the distance and their confidence score. The other one is just to get the closest body part, but the confidence score should cross a certain threshold.
Great.
Okay.
Thank you, Jinhui. We're going to have to move on to the next team.
Yeah.
We have team 5 and 7 here. I'm looking at the.
And we have to. We also have one slide to share about our team members. I'd like to thank Yixin, Xingyue, and Mengmeng. This is our effort together. Thank you, guys.
Great. Thank you. All right, so let's move on to team number 5. Adiola, I see that you're the one with team number 5 on your name.
Yeah, we are team 5.
Great.
Yeah.
Do you have a slide to present?
No.
Okay, then just in a couple of minutes, tell us about your approach and difficulties and successes.
Yeah. Okay, my name is Yue Zhang. I'm come from University of California, Merced. First, I want to say it's very interesting to participate in this competition, and we are interested in the matching of multi-sensing modality. So yeah, the basic idea of system is that we use a location aware information to merge the weight sensor result and the camera result. So from the shelf location, we can know the weight sensor locations. And so we use this information to trigger the camera data processing. And when we processing the camera data, we mark each shelf's location from each camera side. So, if you pick up something, your hand's location will match with the shelf location from the camera side. So we use this location information to combine the camera data with the weight sensor data. This is the basic idea of our system. I think Adiola later can introduce more detail about this part. What I wanted to say, other thing is that our team, our teammate is coming from 5 universities and in different countries, Australia, China, US, and it's very interesting to, collaborate with them. And I learned a lot of things, and thanks for this amazing team. Yeah, that's all.
Thank you, Yuri. I saw that your team was very, very spread wide in the world. We have another team here. I think we have team 7 on the call. Hey, Nishan, do you want to quickly present your approach? We're running tight on time. If you can keep it to 1 or 2 minutes, would be great.
Okay, I'll forgive the slide then, but our approach was strictly weight sensor based, and we actually had a lot of similarities with team 3, where we kept track of our own planogram and updated that in real time, and we assigned the product with the closest weight change to what we detected to the nearest customer according to the planogram data. And we also had a similar system for putting back items where we scanned each customer's cart for the object of the nearest weight.
And any particular challenges on that, or how do you feel it went?
Yeah, one of the major challenges we faced was duplicate items. So we had problems with synchronization between the sensor data and the video frames, which was when we're starting our sensor data's capture, or when we started running our algorithm on the sensor data. And I think the duplicate items issue might have been due to our approach, because we separated each of the sensors into different groups. And some of the items were resting on multiple groups, so they got picked up multiple times when they were removed from the shelf. And that actually led us to not being able to successfully submit all of our test cases.
I see. Yeah. So weight, although sometimes it seems like weight is a simpler solution, it has its challenges as well. I'm going to move on to team 6. I think Yitao and Yiwen, you're there. Let's try to keep it to 1 minute or 2.
Okay, so our model were basically combining weight sensor and vision fusions, and the part that we want to focusing on is the part of computer vision, where we have this combination of post estimation and image classification. And what we are trying to do is to find the optimal proposed window of those items, because we want to keep tracking on what's on the item, what item is on the customer's hand, so that we can deal with multi-person shopping situations. So we had this post estimation and keep tracking on the wrist coordinates, so that we can create a small sliding window that are centered at the coordinates of the customer's wrists, and then keep tracking on what's on what item can be classified within that window. Here's a video that we could show about how we find out the the coordinates. First, we create a mask mapping how the mapping the only thing that are left with that can show the figure of the people, and then we could get a slugging window from that figure that are already being subtracted by the background. And the other trick that we're using is sort of like a static inventory monitoring, where we have a static comparison of what has been changed before and after a shopping event. And the window that we find, it's quite accurate by looking at this change on the pictures, by looking at the difference of RGB similarity. And we're trying to develop further on, say, like the flashing on the lights and the different coloring of the situations when the sunlights are shifting, and different kind of lighting situations like that. Yeah, that's basically what we are trying to do.
That's a really, really interesting approach. We're 9 minutes from the end, so I'm not sure if we have any other team here. If there is, please raise your hand or speak. I don't think there is one. So thank you all for your presentations. Really interesting approaches, and it was great to work with you and see how you were tackling the problem. One of our early intentions was to enable you as well to put any hardware that you thought that could help and any other creative things. But unfortunately, we couldn't do the physical aspect. But I'm really happy to see that even though we couldn't do that, you guys came up with very different approaches and all were able to submit and have your results. So round of applause for all of you. Thank you. So I'm going to start sharing my screen again. On to the what you're all waiting for, which is the winner is team number 3, and the animations are So the way the F1 score is computed is, as I mentioned before, it's computed across the entire baseline plus the team requested scenarios on day 2 and some of the team scenarios on day 1 from the teams that asked to include those in there. By the way, these results were very interesting to see appear. Team 3 showed up very early on, but Team 6 started to, the last few hours of the competition, I thought you guys were gonna catch them. It was very, very interesting to see. Also, this reflects probably 20 or 15 minutes before midnight. So if you've submitted something closer to midnight, I believe this will change. Carlos just did we rerun it. Didn't change. It may change a little bit the percentage, but it doesn't change the result. So, and Team 5, congratulations. I also want to say Team 1, 2, 4, 7, and 8. If you're here, they also did pretty good. I think some of them had some troubles. I think one of them is the HEB who couldn't submit, but there were some technical troubles. I'm very happy to see that the 3 of you were able to do it. I do want to show you, I'm going to try to show you something, some more details, some statistics about the competition. I have to stop sharing my screen and share again. This desktop share. You're sharing it. Yeah, but it was an image. Okay. So we have 6 minutes. I'm going to share some details over here. Oops, wrong window. There we go. This is the one you already saw, the F1 score. Where should I go?
So if you click on the bottom, you can see each teams. So if you want to see all of them together, go to the right. There
So
you go.
this plot over here shows you the 3 finalist teams across their performance across the scenarios. So you can see that team 3 and 6 did quite well in the simple cases. Team 5 didn't submit some of the early cases or submitted 0. And it's actually interesting to see how it broke down through the scenarios. Further analysis could say that visual approaches solve certain cases and weight approaches solve other cases. We're gonna make sure to look at it and give you some feedback.
Yeah, we can also share with them, I guess, each team's individual performance. Team 3 was pretty robust. Very good job, guys. So each of the teams, if you click on your tab, I don't know, maybe we can share at least the images or the spreadsheet. You can see your performance. I believe some of these cases, either because of time or like some of the teams had trouble making it at the end. So, you know, also some lessons to learn, try to start working on these things earlier, especially vision. You know, it takes long. From experience, I can tell you as well. So, but yeah, overall, everyone did pretty amazing. So it's very exciting to see.
I believe that this case over here
is the
it's the 97% of the
Yeah.
Carlos stealing all the
just
popcorn. So this was, again, thank you all for I don't know what happened here. Okay, for participating, and but I do want to say that this is just the beginning. This is the first of many, and we're opening up. You've all experienced all these challenges and all these fields that you can research. I know that Team 3 had all amazing ideas to implement on the vision side. I know Team 6, we were thinking about doing more weight, and we were talking about objects that came only from places without weight. So there's lots of exploration work that we can do. This competition was intended to create a platform for all of you to come together and study this domain in the same place. It's very hard to get these data sets. They're not readily available, especially with COVID. It's even harder to get to nowadays. So we're releasing this data set, and we're going to collect more data set, and we're going to make that available as well. Which is the second part of the competition, was intended to have all of your creative ideas in the scenarios, all of the baselines, all available, and sanity checks to make sure that you could use it. So this was a fantastic venue for that. What are we working towards? We're working towards releasing a large data set of real shoppers. And this, when I mean large data sets, we're actually working with IFI together to get a real store with real customers that can opt in to provide their data. So when they go in, it just goes into the database and becomes immediately publicly available. Our idea is to run this over a span of months, and you can imagine the insights that we can extract from that type of data. At the same time, since real shoppers, there's difficulty there. Some people may be privacy sensitive, so they won't opt in. But we do intend to release a simulated shoppers and objects. So if you know our store, here's a simulation of our store with the key points annotated. You have perfect ground truth here. So you can generate thousands and thousands of scenarios or millions of scenarios in cases from the simulation. And we have 1 minute left. So we also intend to release a post-COVID physical competition. Thank you for being here, and thank you for all your effort and bearing with us, as this is our first one. And I hope to see you in the next one.
Before we go, I would like to say this, the COVID thing happened, and JD did an amazing job, and Carlos and the entire team did an amazing job putting all these from a physical competition into an online competition in a matter of a very short time. I actually don't remember how long, but it just seemed to happen overnight. And so thank you all for organizing this thing, and you guys did a great job. Virtual class.
Thank you. All right. That's all I have. I think the meeting went right on time, and I know it's very late for all of you, so have a good night, rest. And if you're interested, keep submitting. It will not count for your score. I do want to say you need to submit your code as per the instructions to validate these scores and so that you get your prizes. There are prizes, and first prize will be $1,000, second prize $600, and the third prize $200. So congratulations all.
Yay.
You can only get your prize if you submit the code and the tests are validated. So do submit your code until tomorrow, midnight, anywhere on Earth. Thank you.
Before we go, JD, can you stop sharing screen? I will take a screenshot and that will serve as a photo.
Sure.
Oh, yeah.
So if you're willing, please turn on your cameras and everyone smile. Okay, sorry, I don't know how to do this. 1 second. Smile, 1, 2, 3. Okay, thank you.
Nice.
All right.
All right. Yeah, looking forward to the next one. Hopefully physical, so some of you can show your skills with other sensors.
Yeah, and we're going to write a publication about this, and I'll reach out to all of you to get your insights and your contributions onto that paper. Thank you.
Awesome.
Bye.
All right. Have a good night, everybody.
Bye.
Thank you. Bye. Have a good night.
Thank you.
Thank
Bye.
you. Bye.
Bye. Bye-bye.